Welcome, ladies and gentlemen, to another episode of the Nerd Chronicles. This is your host, proud lame, socially awkward nerd, socially awkward, certified beta male, simp mangina, whatever it is you want to call it. Christian Paul is in the building today. And what we will actually be discussing and what I will be lecturing today, for folks that are unaware about all this corner deals, I want you guys to actually get yourself dug into the elementary aspect of Numerical Python, NumPy for short, right? So we're going to go through some basic fundamentals, some basic how-tos. I'm actually at the NumPy site. It's numpy.org, which you actually can find literally below. The link should be in the description below for those who actually want to actually try and dig more into and actually see more advanced coding at your will. But we're going to focus more on the elementary aspect for folks that haven't really fully understood NumPy or actually want to actually try to learn more and get a good deep sneak peek into the data science world. NumPy is your primary source to go in order to solve your problems, right? So they have this current model here, NumPy 1.2 through 23.0. Is basically the fundamental package for scientific computing with Python, scientific analysis, powerful ND arrays, and dimensional arrays, and that's why we got the code ND array for short. Numerical computing tools, interoperable, which it shows, performance, easy use, and it's an open source library that's mainly free, right? So we already have this NumPy that they have up here, which you can barely run. Okay, so we have that already imported. So we already got that stuff done here, and you can go with a 2D array that they have. X equals NP arrange 15. Right, and I could just type this in so folks could actually get a good understanding of what I'm doing. Alright, and then you reshape, you get the command in the specific section if you want informed. And then X would be, you want to make sure we get this in the way here. And they basically are angling the first array to actually be set, and then anywhere basically except the second to last, they want everything to equal 99 from bottom to end, right? So let's see if we can try to run this guy, see if we get an outcome. Okay, so far so good. D type integer 64, which was shown, and then you have all this stuff that's here. I'm not gonna actually do too much coding. Scientific domains, right? Nearly every scientist working in Python draws on the power of NumPy, which include data scientists as well. But we're going to actually go through the general aspect of NumPy and see how it works. NumPy brings the computational power of languages like C and Fortran to Python. A language much easier to learn and use. With this power comes simplicity. A solution in NumPy is often clear and elegant. Quantum computing, and they have the codes for this: Q-tip, PyCode, QuizKit, Penny Lane, statistical computing, Pandas, Stats Models, X-Array, Seaborn, signal processing, SciPy, PyWavelets, Python control, image processing, Scikit image, OpenCV, Mahodas, Graph Networks, Network KX, GraphTool, iGraph, PyGSP, astronomy processor you see here, cognitive psychology you see up there, all the packages that's shown below you have to install through Anaconda or pip. Bioinformatics, mainly biomedical engineering or scientist level, this is what you have to be dealing with. Bayesian interference, same thing. Mathematical analysis as well. Chemistry, Quantera, and the analysis, blah blah blah. Geoscience, you got processing, architecture, and engineering. You see why you go to grad school, or if you major in applied math, statistics, or even any form of engineering in your undergrad or even graduate, they're making people do Python now. Mark my words, I put money on it. Okay? Do it fast as a fast from source in MATLAB, or if you're doing like an introduction to computer science, a lot of folks are going to be relying on Python now for detailed coding. Alright, this will give you like a quick warning. These are your scientific domains. Your array libraries is shown, right? All of these are shown below. You could definitely look at all of these below and actually install them and install them through your Conda forges, Anaconda, or pip, right? We're gonna get these done. We're not gonna go through like each one of these below. A lot of them they have within the packages actually used, but click on them, read them, do your research, and see how they work. And once I'll go over the basics, that's more so with the data science realm, right? Now we can focus on data science. Pandas, beautiful soup, intake, gonna be like another one. Seaborn, Matplotlib, NumPy, TensorFlow, scikit-learn, SciP, basically data modeling, SM, data presentation, Matplotlib, Holoviz, Viz, P, right? Right there, you see all these packages that are shown, already set up. You deal with extremely high data volumes, data space design and scalable deployments relying on data versioning, experiment tracking, MLflow and workflow automation, which is definitely showing machine learning, right? You got all these models you want to try and compare, scikit-learn, SciP, as just for an example. Machine learning grows, so this list of libraries built on NumPy, TensorFlow, same way. PyTorch setup, MXNet, another AI package they had deals with deep learning. XGBoost like GBM, Cat Boost is right on the LML algorithm, Silverbrick and Eli 5. Deal with like machine learning visualizations. Alright? We got them called ensemble methods. And we go through visualization here. NumPy is like the primary elementary foundational source in order to get some things done. Right? All these packages you see up below that you use, you got all these options that are set up there. Right? Let's go to case studies. You got the black hole set up. You can definitely click on it below for more info if you want to actually dig more for yourself. Gravitational waves, sports analytics, right? NumPy sets it up for you. Post estimate to be deep learning. Everything is all fully set. Now let's do the elementary nitty gritty. Ladies and gentlemen, we are in the NumPy documentation. We are in the NumPy documentation here. Basically actually getting themselves set up with the getting started for the elementary users, as well as a full-on user guide, API reference, and contributors guide. The API reference is mainly for software developers to actually develop new concepts, as well as contributors. Those are mainly for folks that want to be involved in software development, or more so in like the computer, deep computer science world of coding there, right? But if for those that are actually more curious and actually want to dig more into NumPy, these sites are mainly below. But right now we're gonna actually dig more into your elementary ordeal so that folks can understand the basic how-tos on how stuff is really being modeled. Let's get into it. Ladies and gentlemen, welcome to NumPy. Right, and it's self-explanatory, basically what it is below. That's actually all set up on what NumPy is about, which we really discussed. Now installing it, Conda pip, you type it up in basically up in your terminal, command center, respectively in your Mac or Windows, or you can go to Anaconda and actually try to install it from there within that system, and then look for NumPy. You should be good to go, right? You know, Python, use Anaconda. They have all the Python stuff that's really there below. That's actually very easy and simple to do. Important is actually very simple, easy peasy as pie. Go to Spider, or go to Jupyter Notebook, and then directly type in important NumPy, or if you like to do Python 3.0, go to your terminal and import it. You should be good to go. Reading code. Right? If you're not fully comfortable reading tutorials that contain a lot of code as of yet, you may not have any idea of actually how to interpret something like this, right? So, left side basically talks with like input, right side deals with command or outputs. That's basically what it means. The dot basically talks about like a certain column or a certain it's basically like a certain set of commands that you're trying to focus on within that array or matrix, right? So that's basically what it is. So signal on the arrow is basically saying input. Everything that doesn't have this type of signal here that's in front is the output, or the results basically running the code. And this is where you see we have the Python command line. blah blah blah. Now it can be safely typed to paste in Python shell, which this error here is ignored. Now we can deal with some difference between the Python list and arrays, right? NumPy gives you like various options that are very quick and easy to do, while Python list can create different data types from a single list. All the elements in NumPy arrays should be extremely homogeneous. Mathematical operations that are meant to be performed in arrays would be extremely inefficient if the arrays were not homogeneous, right? And they give a proposal saying why use NumPy, because they claim they're actually more fast and compact and simple than Python lists, which you already know. An array, which array is a set of data structure in the NumPy library, which is a grid of values and contains information about the raw data, how to locate an element, and how to interpret an element. And they have a grid of elements that can be indexed in various ways. That's referred to all the same type that's referred to as the D type. Arrays can be indexed by a tuple of non-negative integers, by booleans, by another array, or by integers. Regularly arrays the number of dimensions. Shape of the arrays to tuple of integers given the size array along each dimension. One way can analyze NumPy arrays Python lists using nested lists for 2 or higher dimensional data. So top line here is only 1D, or a top line here could be a 3x4 matrix here, right? Rows being 3 rows going by 3, and then 4 is basically the columns. Alright, now you access the elements in the array, use square brackets, and actually print them below. They have more information if you actually want to try and dig this in further detail. And they have all these arrays that are there that you can actually literally look up. And we have dimensions being called axes. That means you have a 2D array that looks like this. The array has 2 axes. First axis has a length of 2. Second axis has a length of 3. Right? I'm trying to make sure we get all that stuff literally set up. Right? So 0, 1, that's the first. That's basically talks about within the rows. Right? And the column deals with the length of 3. Right? Column has the 3, hence 2x3 matrix. Right? Just like in a Python, container objects an array can be accessed and modified by indexing or slicing the array. Unlike the typical container objects, arrays can share the same data, so changes made on one array might be visible on another. Array attributes reflect information intrinsic to the array itself. If you need to get or even set properties of an array without creating a new array, you can often access an array through its attributes. And the base array that's actually set up, so import NumPy, get a variable, set up the NP array, you have your list right here. So 1-2-3 focuses on one column that is a 3x1 matrix. Now, if you take away the commas, you are dealing with a 1x3 matrix because you have dealing with 3 columns all in the same row, right? You got creating arrays, there's zeros. They have a bunch of examples there that you can actually look up in the site on numpy.org. Okay, empty basically creates array, which in this kind of depends on the state of the memory of your computer, right? We can use empty over zeros. Some similar is speed. Just make sure to fill every element afterwards. And create an array arrays elements that's set. MP range of 4. An array contains arrays of union space intervals. You can stretch out the first number, last number, and the step size. So you have first number being 2, last number being 9, step size being 2, right? So it's gonna go by elements of 2, not going past the end point. So you got start point 2, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. You have a 4x1 matrix set up. If it goes by 9, 8 plus 2 is 10, can't go past 9, stops right there. Alright, that's how it works. NP linspace, creating an array values that are space linear specified interval. So linspace 0 to 10 where numbers are equal to 5. You break down the numbers basically within 5, basically within 2.5 between the two. So 10 divided by 5, or because they're doing it in quarters, start point is 0, end point is 10. So you have to split it up in 4 in the quarters. So the quarterly dividends would be 2.5, 0, 2.5, 5, 7.5, 10. Specifying a data type, while the default data type is floating point np.float6fo. You can explicitly specify which data type you want using the D type keyword, and adding, removing, and sorting elements, right? You got that set up here. Now, you covered sorting, right? You got sorting element, simple NP sort. You do with this array. You quickly sort it based on numerical order, right? That's ascending. And that's what sorting is all about. You got arg sort, indirectly sort along search side axis. Lex sort, indirect stable sort on multiple keys. Search sorter, which will find elements in sorted array. And partition, which is a parcel sort, right? You can look that up below, and these are examples that are actually shown here below. And the shape and size, right? Ndim tells you the number of axes dimensions of the array. Size tells you the number of overall elements of the array, which is the product of the elements of the array shape. And then the shape basically shows you n by n, right? It's a tuple of integers that then create the number of elements sorted along each dimension of the array. So you got a 2 array with 2 rows, 3 columns. Shape your array is 2, 3. But if you create this array, 1, 2, 3, 4, 1, 2, 3, 4, right? Basically, we have 2 rows, 4 columns, 2 by 4 matrix, okay? Or if you do 2 by 4 here, 2 by 4 here, 2 by 4 here, output is going to be 2 by 4. And total number of elements, you run 24. And you got the shape. You're basically trying to set up basically like a 3 by 2 by 4 matrix that's actually shown, right? You got the dimensions there, you got the size there. You're basically getting like a 3D model, right? Arrays can definitely be reshaped using this function here. I don't have to actually do all the reading. You can actually do this up by yourself. Do NP arrays and you print it, boom, right there. Reshape, same thing. And you print the angles, get all that stuff, boom, right? 3 by 2 matrix, okay? Now you can specify a few awesome parameters that you can actually have shown, and you can definitely try to look at that stuff below, right? So now, since we have all these topics that we want to actually deal with here, and I want to make sure everyone is on the same page so far with this delivery. You got A, ready to be shaped. New shape is the new shape you basically want. You can specify an integer or a tuple of integers. If you specify an integer, resolve your array at length. Shapes to be compatible with the original shape. C means to write order. C means to rewrite the elements using C-like index order. F means to write the elements using 410 index-like order. A means to rewrite the elements in 410 like index order to 410 continuous in memory. C-like order elsewise, which is an optional parameter. Now, you can learn more about this. Just click the link, okay, where I'm actually having the highlight below. Now, how do we convert a 1D array into a 2D array, which basically adds the new axis to an array? Basically, use the add NP new axis and expand dimensions to reach the dimension of the existing array. Using the new axis will increase the dimension of your array by being one dimension when used once. This means that a 1D array become a 2D array, a 2D array become a 3D array, and so on and so forth. So we got these examples here. You got all the shapes actually listed below, and they have new axes come up with a new axis. NP new axis, you get the semicolon down, A2 shape, 1 by 6 matrix, right? Basically getting like a transpose. You can explicitly convert 1D array out of row vector or column vector using NP new axis, NP.new axis, excuse me. For example, convert the 1D array to a row vector by inserting an axis on the first dimension, which is shown here. Or for a column vector, you can insert a new axis along the second dimension as well. And that's how they have the shape. And you can also expand the array by inserting new axes. Axis is specified position with np.expand underscore dims. Right? And you start with this array and then you use that formula. Boom. Right there. We got more examples they have there. Indexing and slicing. You can index and slice NumPy arrays the same way you slice Python lists. Right? This is what we have shown in the example. You got everything set below, and this is how it's visualized, and this is how it would be done. Boom, 1, 2, 3. Data 0, data 1, data 0 to 2. You got 0 and 1, doesn't go past 2. You got 1 dash, takes 1 away, focus on 2, 3. You can take -2 out, still takes 2 away, because you're dealing with the same matrices here. And then you got these differences here, that's how you view them. Right? You may want to take a section array or circle array elements used for analysis or additional operations. To do that, you need a subset slash index your arrays. And if you want to select values from array that fulfill certain conditions, it's straightforward with NumPy. And you got all these examples here. All of these here, all of these that are basically shown. And you definitely read those here below. Alright? These are the ones we want to try and focus on. Now, right there, creating an array from existing data, right? And you can easily create a new array from sectioning off an existing array. And you say you have this array that's actually shown below, and you can create a new array from a sectioning array anytime except from where you want to slice it. So R1 is basically this guy here, 3 to 8. So take out 3 and go 4, 5, 6, 7, 8, and boom, right there, right? You grab the section array by index position 3 through index position 8, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 0 to 9, that's how it starts in Python, right? This is where the array is actually going to be, and this is where you want to get. So position 3 through index position 8. So this is where it will start. 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, and 9. It doesn't actually go through at that point. And boom, this is what we get. You get a difference of 5. Now stack 2 position arrays, both vertically and horizontally. Let's see what we get. These are the angles. You do the V stack. 1, 1, 2, 2, 3, 3, 3, 4. Stack them all together, or horizontally. 1, 1, 3, 3, 2, 2, 4, 4. You got the A stack formula and the V stack formula respectively. And arrays can be split, right? Using the split that they have shown. So we have this array that's actually down below. NP arrange, and you reshape it. Boom. Now you want to split this array in 3 equally shaped arrays. You will use 8 splits for that formula. 1, 2, 3, 4. You got all these arrays you have listed below. Now, split your array after the 3rd and 4th column, you'd run this guy here. Alright? This is all you run it. Stacking and splitting. And then you get the view method to create a new array out, so it looks at the same data as the original array. Which views are a very important NumPy concept. NumPy functions, as well as operators like indexing and slicing, are going to return views whenever possible, and they got an example like this below. Okay, and you create all these arrays that are actually shown. You do the copy method, and you do a decopy. Boom. Basic array operations. Once the arrays are created, you can start to work with them. And let's say you got 2 arrays, one called data and one called ones. And you can combine them with the plus sign. Boom. 1, 2, plus 1, 1, matrix 2, 3. It's just like with matrix arithmetic, right? You know, matrix vectors, addition, subtraction, multiplication, division, right? It's just like when you're doing with mathematical matrices or matrix computation, right? At high level, advanced pornographic mathematics, right? And again, subtraction, multiplication, division, right? You see these guys here below. No matter how many arrays you have, whether it's 1D, 2D, or ND, right? Still the same practice, still the same theory. And you do the sum of the axis of rows, boom, still the same theory. And broadcasting, and let's do broadcasting, ladies and gentlemen. There are times when you might want to carry out an operation between an array and a single number, also called an operation between a vector and a scalar, or between arrays of 2 different sizes. For example, your array will call the data might contain information about distance in miles, so you want to convert the information to kilometers. You can perform this operation with this guy here below. Multiply that below. This is what we would get. You're basically doing like distributed property based on the matrix that you see here. They call this broadcasting, right? This is what broadcasting would be about. More operators to use. Then you got aggregation functions. You got min, max, sum, and you got mean. That's the average. Production get the result, multiplying the elements together. And SCD is standard deviation. And what you see here below, boom, right? Sum, basically, that gives the max number is basically 3. Minimum is 1. Sum gives 6, right? We got the array, still the same idea. Now, creating the matrices, right? NP array. Matrices are up there. This is what we get. And you index and slice your operations when you actually try to manipulate matrices. And for folks that actually learn engineering and math, you guys already know what I'm talking about right here. Okay? You see all this, right? You see all this that's there. Okay? All of this that's here you can see below. Boom, boom, boom. Random numbers, right? All this code. Now, generating random numbers, okay? Use of random number generation is an important part of the configuration and evaluation of many numerical and machine learning algorithms. What do you need to randomly initialize weights in an artificial neural network? Split data into random sets or randomly stuffing your data set. Being able to generate random numbers, actually repeatable pseudo-random numbers, is essential. With generating integers, and I'm going to tell you, this is a lot of stuff they could definitely do. They got every single thing that's here, right? You can actually just go look at the stuff yourself, would actually try to dig more into. They got a lot of stuff that you can actually try to learn here. Transposing, reshaping matrices, right? Reshape, transpose, they have that there. They have all the information, mathematical formulas. You got the square and predictions and labels, saving and loading objects. You have that's there. Doc string, which is what we know. Importing, exporting the CSV. This is where pandas comes in, which we will actually be discussing more in a different episode. Matplotlib, same thing. We're actually going to discuss more of this in a different episode. We'll be digging into more of these down below, right? Because if we go through every single section that's here, we are going to be set for now. You guys are actually going to tune out on what I'm explaining. So let's go dig into the fundamentals, right? All right, so what have we learned so far, right? Array creation, NumPy, data types, broadcasting, byte swapping, custom arrays, subclassing, all these basics. You know what I mean? A lot of craziness that's really coming about. So, for those that actually underwent schooling in mathematics, physics, advanced mathematics, advanced physics, and in a graduate level, or even in the highest spot in the undergraduate level when you have to be dealing with Python, NumPy probably have definitely been your favorite best friend. And for those who actually fully get it, actually are dealing with that type of material that actually want to learn, NumPy is your foundation in order to get through coding. Alright? This is something that you need to get through coding, because I can actually tell you this. I can tell you this when I'm dealing with engineering and mathematics, when dealing with a bunch of basic regressing and analytical work. This is what they have you doing up in the physics courses, the graduate physics courses, as well as the graduate mathematics courses, engineering courses. Having some ordeals to actually try to get you prepared, to actually give you a glimpse or a sneak peek of what the software is like. So, Chris and Paul here will call it a day on this matter, right? He will be back next time to discuss more about pandas, and you guys better be ready for that one. All right. So again, go to numpy.org in order to actually dig more up into the package that's here. So you'll be actually able to try to find other ways to try to master these formulas and master the code that you have here to fully understand how NumPy works, how its packages work, as well as some of its commands. It's best to actually try to get to know and actually take the time to actually read and analyze a little bit deeper. If there's any other questions, you can definitely let me know in the comment section. Like, subscribe, share the video, click on the notification bell for more how-tos in relation to this one. Deuces, deuces, deuces.